Section 15. Revision. Introduction. Having learned so much in the last 14 study sessions, you will use this last session to review what you have learned so far. Learning outcomes. At the end of this study session, you should have reviewed 1. The differences and similarities between file systems and databases. 2. The basic building blocks of data models. 3. The structure and characteristics of relational models objects. 4. The relationship types in ER modeling. 5. The 3 forms of normalization. 6. How to retrieve data from databases using the SQL. 7. The functionalities of databases. File systems and databases. In study section 1, you learned that the file system stores records in a hierarchical tree-like structure and often requires extensive programming, especially in the case of updates, insertions, or deletions. Databases help store data in a compact structure which facilitates the management and retrieval of data. Some of the advantages of databases over file systems include data independence, no data redundancy, structural independence, reduced application development time, and the availability data modeling and design. Data models. In section 2, we study the different data models available for data design and how they have evolved over the years. Some of the data models we mentioned were the hierarchical model, the network model, the relational model, the entity relationship model, the object-oriented model, and the object relational or extended relational model. The relational model. In section 4, 5, and 6, you discussed extensively on the relational model. We defined the table as a structure with rows and columns, and each row-column intersection gives a single attribute value. We explained the different types of attributes: composite attributes, derived attributes, key attributes. He also explained the cardinalities and connectivities of relationships as 1M, 1-1, and MN. We explained the relationship participation constraints. He also looked at indexing and its role in locating database entries. In lesson 6, particularly, we studied the relational algebra operators which guided our understanding of SQL discussed in section 12 and 13. The ER model. In section 7 and 8, you studied the ER and EER models and looked at the various components involved in building such models with their respective diagrams. Just like other data models, we said that the ER model used entities, attributes, and relationships to model data for a database. The EER adds more semantics to ER to allow it to define more complex concepts such as entity, supertype, subtype relationships, and entity clustering. Database normalization. Database normalization was treated in section 10 and 11, and we emphasized the need to normalize the database even after modeling it is to avoid data redundancy. The relational database obtainable from an ER or EER model is in the lowest normal for 1NF, which contains a lot of redundant data. With normalization, we are able to take the database to a state of reduced redundancy by identifying dependencies within tables, leading to the creation of more tables. We also stated that we could sometimes need to denormalize databases to allow for easier queries for data retrieval. Structured query language. SQL is the standard language for managing and manipulating the database. SQL, discussed in section 12 and 13, contains 2 major classes of commands: data definition language and data manipulation language. You studied extensively the select command, which is used for retrieve data from database tables, and studied the various forms in which it could be used to specify conditions on the type, size, or location of data to be retrieved from the database. The functionalities of databases. Finally, in section 14, we study the various functionalities of databases and discuss them under the headings query processing, transaction management, concurrency control, and physical design, which include database workload and database tuning. This is the end of CIS 201. Thanks for listening.